Hi, this video is for Wednesday, April 22nd for calculus. And this is a big moment because it's our last new concept. So the last new concept I'm going to teach you about is the nth term test. It's for convergence or divergence of a series, and it's based around the limit of your series. Okay, so even though this is our last new concept, next week we're going to wrap things up and we're going to review one more time derivatives and integrals. So we're going to be deriving and integrating one last time because that is the main point of calculus. And I want to make sure that you have strong foundation in that when you move on to whatever math class you take next. So that's the plan. Alright, so are you ready for nth term test? Alright, let's go. Alright, so the following theorem states that if a series converges, the limit of its nth term must be 0. You can probably hear my neighbor's dog barking right now. It barks all the time. You can tell how much I love that, can't you? Alright, so here we go. Theorem 9.8. It says, limit of the nth term of a convergent series. So we're going to have this sigma again from yesterday, starting with n equals 1 all the way up to infinity. Okay, so if this series converges, then that means that the limit as n approaches infinity of a sub n has to equal 0. So you find the limit of your series and it equals 0. That means that it converges. Okay, so following that, we have theorem 9.9, which kind of says the converse. So theorem 9.9 says nth term test for divergence. So if the limit as n approaches infinity of a sub n does not equal 0, then it's saying that the series diverges. Okay, so what that means in a nutshell is if you find the limit of your series and it's 0, it converges. If you find the limit of your series and it's anything else other than 0, it diverges. Okay, so we have using the nth term divergence test to determine convergence or divergence. So I'm going to show you how it works. I have 3 examples, and then you will have a Google form on it. And on your Google form, all you have to do is practice finding the limit, which we have done before, and I'm going to remind you how to do that. And you just have to click convergent or divergent. So you just have to click which bubble is it, convergent or divergent. Alright, so here we go. Alright, so example 1, we have the series starting with n equals 1 to infinity, and it is 6 over n times n plus 3, like that. Okay, we're going to focus on this 6 over n times n plus 3 part. Okay, so I'm going to rewrite it slightly. I'm going to distribute this, so n squared plus 3n. Okay, I have to find the limit of this as n approaches infinity. So now this should look slightly familiar because we've done problems like this before, and when we found the limit, we divided by the highest power of n. So do you recall doing that? Dividing by the highest power of n to find the limit? Because that's what we're going to do. Okay, so the highest power of n here is n squared. So we're going to do 6 over n squared over n squared, and 3n over n squared. Now if you remember before when we found limits, this is going to go to 0, this is going to equal 1, and this is going to go to 0. Okay, so we have 0 over 1, which equals 0. So now, do you remember at the beginning of this lesson when I said if the limit is 0, it converges? So guess what? Since the limit is 0, this series converges. So we're going to write converges. And that's it. We're finished. Okay, so really here you just have to remember that dividing by the highest power of n situation to find the limit. And then if it's 0, you say it converges. If it's not 0, you say it diverges. So that's the point of the lesson. Okay. Alright, example 2. We have the series n equals 1 all the way up to infinity, and we have n over 2n plus 3. Okay, so we're focused on this n over 2n plus 3. And we're trying to find the limit as n approaches infinity. So I'm going to write it down here. So the limit as n approaches infinity of n over 2n plus 3. Alright, so what is the highest power of n in this problem? Just n, right? So we're going to have n over n, 2n over n, and 3 over n. So that's going to be 1 on the top, 2 on the bottom, and this part becomes 0. Is 1/2 equal to 0? No. So we're going to say that this diverges. Okay, so hopefully that's pretty straightforward so far. We've got one last problem that we're going to do together, and then you'll have your Google form for the day. All right. So example 3, we have series n equals 1 to infinity, 1 over n minus 1 over n plus 2. And we're going to find the limit as n approaches infinity of this. Okay, now this you can't really divide by the highest power of n. I mean, you could. But if you just plug in infinity, so we're using direct substitution on this. If you plug in infinity right here, 1 over infinity, that becomes 0. So I'll write that down. Minus 1 over essentially infinity, that's going to become 0. And 0 minus 0 is 0. So we're going to write that it converges. Like that. Okay, so on your Google form, like I said, you just have two choices. Is it convergent or divergent? So you find the limit, like we did on these 3 problems. And then if it's 0, you click convergent. If it's not 0, you click divergent. Okay, now Thursday and Friday, I'm not going to post anything new. You just work on finishing up your assignments for calculus. And then Monday, Tuesday, and Wednesday, possibly Thursday, we're going to review derivatives and integrals. And then that'll be it. That'll be the end of calculus. And I wish I was there in person to tell you all how proud I am of you, and that I think you all do great things. And I wish I could be there to also give you all a hug. But eventually we'll have graduation, and I'll see you at that, and then that'll be great. Okay, so let me know if you need any help. Good luck with your Google form. See ya.